These notes are for the end of the energy unit, and they are about Hess's law. Hess's law. Enthalpy, which is delta H, is the amount of energy or heat that is gained or lost. A positive H is endothermic, a negative H is exothermic. The definition of Hess's law. The total change in enthalpy is the same in a reaction no matter the path of the reaction. For example, if you buy something for $5, you can pay for it with a $5 bill, 5 $1 bills, $10 bills, etc., just as long as you pay for it. Doesn't matter how you get there. How to do Hess's law problems. You'll be given a main reaction in which you'll be asked to find the delta H. Under that reaction, there will be some supporting reactions with delta H values. Use those supporting reactions with the delta H values to calculate the total delta H for the main reaction. To do this, you may need to flip the supporting reactions around. So flipping a reaction around. So if you have this reaction in that direction, and it's a negative 395.2, if you need to flip it around because you need some compounds on the other side, you just flip the sign to a positive. So it was exothermic and now it's endothermic. You can flip all the reactions around, just making sure to change the positive or negative value. You'll flip them or you may not flip them. And you may need to multiply a whole reaction by a number or a fraction. Make sure you do the same to the delta H value. So if in this reaction up here we had to multiply everything in there by 2, we would multiply the 395.2 by 2 also. And then you add up the modified delta H values. So here's an example. This is worksheet number 2, problem number 1. Find the delta H for this reaction. Solid sulfur plus oxygen yields SO2. And you're given this reaction with a negative, and you're given this reaction with a negative. So you have to get these reactions over here to add up vertically to equal that equation. So you know what your answer has to be. No, rats, and I don't have the example on there. Let's do a little bit more on entropy. Define a measure of disorder or randomness. The symbol is S. The more disorder, the more entropy, so positive S. More organization is less entropy, which is a negative S. Let's do some practice. Identify the following as having a positive entropy or a negative entropy. So a messy room. A messy room would be more entropy, a positive S. A clean room would be a negative S. This, let's see, it's going from 2 plus 1 is 3, so it's going from 3 parts to 2 parts, and it's a gas and a gas to a gas. So you're going from more parts to less parts. That must be a negative entropy. It's becoming more organized. Now this one, you're going from a liquid to a gas and a gas. It's becoming more disorganized. That will be a plus S. And you can also go 2 parts are going to 2 plus 1 parts, which is 3. So this one, we have a gas and a gas going to a solid. Ooh, things got way more organized. That's a negative S. Okay, so if you take NaCl and you dissolve it in water, you're going to get more particles because it splits at the Na and the Cl. So that's a positive entropy. Water freezing, the molecules get more organized as something turns into a solid, so that would be a negative S. Those are the end of our notes. Let's see if we can. I think I'm going to end there, and I'll do a Hess's law separately.